there. This video is on how to solve two nonlinear simultaneous equations. So this nonlinear means that they could have x squareds and stuff in them. They don't necessarily both have to be nonlinear equations, but at least one of them is going to be nonlinear in this case. If you saw my video before, unfortunately, this isn't the same as the two linear simultaneous equations. We have to do a method here called substitution, which can be slightly more confusing than the method we did last time, which was called elimination. So same thing here. We always number our equations 1 and 2 so that we know what we're talking about at any given time. So what you do in this case is you go, okay, I want to get an equation where it's x equals something or y equals something. So that's what we do first. So it's easiest to do that with equation 2. So I'm going to take equation 2 where we've got this. If I want to get x is equal to something, then we bring the y over, we do the opposite, so we're adding instead. So 9 plus y it gives us an expression then for x, which is what we want, because then we can go, okay, I can put that into equation 1, and then I'm going to get an expression which just has y in it, and then we can solve to find y. So if I go to equation 1, then instead of the x, we write 9 plus y, like that, because we know that they're the same thing. X is equal to 9 plus y. That's obviously squared because our x is squared up here. And then plus y squared equals 41. So let's expand these brackets. Always rewrite your brackets like this so that you know you're definitely having to expand them using the FOIL method or whatever way you call that method. A lot of people use FOIL, but as long as you can expand the brackets, you're grand. So if I expand these brackets, we do 9 times 9 is 81. 9 times y is plus 9y. Y times 9 is plus 9y. And y times y is plus y squared. And then we've got our other plus y squared here equal 41. So now we've got squareds, we've got y squareds, we've got y's, we've got numbers. We want to form a symbol or a quadratic equation. So if we group I'll put circles around the y squareds, squares around the y's, and then triangles around the numbers. And then we know what we're grouping together. So the y squareds form 2y squared plus 18y. And obviously in this case, you're going to have to bring the 41 over here, which means you're going to have to take it away from the 81, which means that we get plus 40. Now, I always recognize whenever we're doing quadratic equations, if we can simplify this anymore, these are all a factor of, or a multiple of 2. So we can divide the whole equation by 2 to make it a bit simpler. So y squared plus 9y plus 20 equals 0. And now you factorize your equation. In this case, it's going to be plus 5 plus 4. So y either equals minus 5 or y equals minus 4. So if we put those two values back into our equation, it's easiest to put it back into this equation because you've already got a value for, it's just x equals that. So if we put minus 5 into it, then we're going to get 9 minus 5 is equal to 4. So x is equal to 4, or x is equal to, and if we put minus 4 into this, then 9 minus 4 gives us 5. And you can see here that if we put these values back into equation 2 here, then 4 minus minus 5 gives 9. And if we put these values back in, then 5 minus minus 4 gives 9. And if we look at equation 1, then 4 squared is 16, plus minus 5 squared is 25. and that gives us 41. And you would do the same here, and that also gives us 41. So both those answers are technically right, even though there's a set of them, but it would say to you in the question, it would say what could be the possible values of X and Y. And having two sets is fine in this case because they both work. Sometimes that happens whenever you've got a nonlinear equation involved in this. So thank you very much for listening. I hope that all made sense, and good luck.